Welcome to tutorial number 162. In this tutorial, we will talk about a popular method for determining the sheet metal properties, and we will see what is gauge table and why and where to locate them, use them, and then show you some examples and also show you how you can make your own gauge table depending on your requirements. First, start a new part, and I will make a simple sheet metal beam on front plane and give it some dimensions. Go to the sheet metal, this flange, and the length, make it 200. Click OK. I will assume this is steel beam and the thickness was 1 millimeter, as you see. Now go to the sheet metal properties, edit feature, and as you remember, here are the values which we showed you how to calculate, and here is the K factor. But you may ask yourself that if you are working with few types of sheet metals and you are already know the bending radius and the thickness and the K factor and already calculated the K factor, and ask yourself that these values should have been saved somewhere and used directly without the use to re-enter them. So this is the work of the gauge table. If you look over there, you will notice there is use of gauge table. So this is the method. For example, you can edit your own gauge table and add these values in there, and every time you start a sheet metal part, you just load the gauge table and automatically is a time-saving method, and it is very popular at industries. Before checking the use of gauge table, I would like to locate them on your computer. So they are found on the SolidWorks folder. So if you go to computer, program files, SolidWorks core, and then SolidWorks language and English, here you will find the gauge tables already over the bend tables which we talked about in the previous tutorial. And if you open the gauge table folder, you will see many examples. So each gauge table, depending on the method you are following, so there are gauge tables based on the bend allowance, which we showed you the formula. You have the bend deduction and then the K factor, and there are some sample tables. And we said that be concentrating on the K factors method. So here you have the K factor in inches. If you open that, and you will see there are two thicknesses, but these are inches, and here you see in millimeters. And here you can see the gauge table, and it looks, and this is how the gauge table looks like. It is a bit different than the bending table, and here is the for which material. It is steel, but it is clear it is not the stainless steel because of the value of the K factor. And the process is the air bending K factor based on the K factor units, and then the material is steel. Table is divided by gauges. Gauge number 5 is for thickness 1, and the bend angles as we notice over there. And for the angle 75, the K factor is 0.6 for this type of steel. And for thickness 2, you have the bend radius over there already, and you have the bend angle. So this is what make the gauge table popular, because here it will pick automatically depending on your bending radius and thickness and the type of material you are using. It will directly calculate the key factor for you. So let's go back to SolidWorks, to the part which we made, and now let's check use gauge table. Select based on the key factor, and then here is the steel air bending. We saw it on the table, and even you will see that the thickness is 1, then it should be the gauge number 5. So here is gauge number 5 is picked, and if you pick gauge number 4, you will see the thickness is 2 millimeter, but in our case it is 1 millimeter, and the bend radius it calculated to be 1 millimeter. We can change it or override the radius, for example, but I will keep it for 1 millimeter. For the gauge table here, the bend allowance is gauge table, and when you are done, click OK. So here is browsing our table, and you get, and if you edit the sheet metal feature, you will see all the values over there. So let's make another example. Start a new part. Okay, pick front plane, a sheet metal LB, and we already know that we are working with steel, and the thickness should be 2 millimeter, and the bend radius 2 millimeter. So you just go directly to the base flange, extrude to 100, and use gauge table. Select the type of gauge table. We said that the gauge 4 contain the thickness of 2 millimeter, and the bend allowance I let it to the gauge table to calculate it, and the bend radius here you just can make it 2, and you don't need to think about anything else, because the table will do the work for you. We saw this is a small gauge table, and there is an example I want to show you. So this is an example for a gauge table for the CAD industry, and here is the reference link, and here you can see it's the units in inches, and it is for steel and aluminum, and here you can see the gauge number and the thickness and so on. Modify it to millimeter, and I'll show you how. Change it over there, click enter, And here for the thickness, to change it, it was you just simply type equal the value that you. So this is the original value. You just click equal and change this to millimeter multiplied by 25.4, and you'll get the thickness in millimeter. As well the angle, the radius, you can change it in the same way, and so on with the rest of the values. Here see the so let's see the nearest gauge to our previous example, this one here, with a thickness of 2 millimeter, and here is the thickness and the bending radius is almost 2 millimeter. So it is gauge 14. So let's save this and apply it to example. So edit the sheet metal feature. Here browse for the key factor and select the table, which is click OK, and here is the copy of Chad's table. Click yes, and it will upload the values of your material. And as you remember, we said the nearest gauge is gauge 14. Find it over there. 14 gauge steel, and the values already uploaded. As you remember, we have only one bending radius, and click OK. And here the values are calculated. You can also make your own bend tables. We can go back to the SolidWorks samples, pick one, make a copy, and let's say that is stain steel, and the values we showed you that how you can calculate it in tutorial 160 is 0.38. Let's assume it is the same for the rest of the bending angles. You can fill your gauges by yourself. So for now I'm just deleting these, and also these values, and the rest you can continue. So you can look at which material you are using and which are the angles you are using and the bending radiuses, and fill according to your requirements the table. Make a new part here, the following dimensions: sheet metal 100, use gauge table, and this time browse for the new sample that we made. Select the gauge factor as a copy of our table that we edited, and there is gauge 5. and available thickness is only 1 millimeter because we deleted the rest. Rather, the bending radius is 1 millimeter, and we already calculated the K factor of this. Gauge table or K factor. Click OK.